Alrighty. So we've got section 8.6 here, which is all about the law of cosines. And the law of cosines is a little bit different than the law of sines, but they're similar in the fact that the law of sines, which I'll review here right now, law of sines. Law of sines where we had the sine of an angle over its opposite side would be equal to a sine of another angle over its opposite side, which could also be equal to the ratio of the sine of the last angle to its opposite side. That works for any triangles, not necessarily right triangles. It works for non-right triangles, and so does the law of cosines. But the law of sines doesn't cover every situation because you might not have an opposite side with or one side with its opposite angle. So law of cosines is going to work for those situations that law of cosines is going to work for those situations that the law of sines does not. So the law of cosines looks like this. Um, So again, it says if you don't have a right triangle and you can't use the law of sines, use the law of cosines. So it could look three different ways, but really we're saying right here for the law of cosines or for any triangle ABC, the law of cosines relates the cosine of each angle to the side lengths of the triangle. So if we look at it, we pick a side length, and that's what we're going to be working with, a squared. So look at this first one, a squared, or I mean we're looking at a, but a squared is equal to the other two sides, b squared plus c squared, minus 2 times the other side, two sides, times b times c, times the cosine of that opposite angle. So the angle only comes in there once, and otherwise it's all the rest of the sides. And this one's a hard, really very difficult one to remember. So the more practice we do with it, the more we see it, the better we might get familiar with it. If we pick another side, b squared, it's the same idea. B squared is equal to the opposite two sides, so a squared plus b squared, minus 2 times a times c times the cosine of b. And the same thing applies then for c squared if we're dealing with c and its opposite angle. So let's do a couple examples with this right now. It says in triangle ABC, so we're just going to draw out a triangle. Doesn't matter if it's perfect. A, B, C. We know the measure of angle for A is 45 degrees. We know that AB is 20 and that AC is 15. We do not have an angle and its opposite side to use the law of sines. We do not know that it's a right triangle to use any of the trig ratios. So we're going to have to use the law of cosines. And we're trying to find BC. So to find BC, we're going to make that x, or really that would be lowercase a. A squared is going to be equal to 20 squared plus 15 squared minus 2 times 20 times 15 times the cosine of that angle of 45. So now to solve for a, we simplify everything on the right, and then we take the square root of it, obviously. So what we're going to have here is really this is 20 squared plus 15 squared, so that'd be 400 um, plus, what is 15 squared? 225. So 400 plus 225, that's 625 minus 2 times 20 is 40. And 40 times 15, again, have your calculator handy when you're doing this, minus 600 cosine of 45. And that's going to be equal, so A would be equal to the square root of all of that. So I'm going to take my calculator and do that. Doing that, and I get A is equal to, it says what is to the nearest tenth, I get 14.2. And that seems realistic since one side is 20. It's okay that another side is 14. If it was like 700, then we might see a red flag. Or if it was like really, 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 really small, then that would throw a red flag as well. But we found AC or BC would be 14.2. Just using that law of cosines. Let's try it again. It says for number 2 in triangle PQR, we know that the measure of angle Q is 110. that the measure of, or that PQ is, oops, PQ is 8, and the QR is 12, and we want to find PR. So we'll make this one our A or our X squared or whatever we want to make it. Actually, it'll be lowercase q, but yeah, we'll do that. So Q squared is equal to the opposite two sides. So we have 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of 110 is what we're dealing with here. So again, to find what Q is, it'd be the square root of all of that. So 8 squared would be 64 plus 144 would be 210, I believe. Wait, 164 plus 144, sorry, 208. 208 minus 16 times 12 minus 192 cosine of 110. Alright, now you're really going to need a calculator for this. But I'll do 208 minus 192 cosine of 110. I got 273, and I'm going to take the square root of that then. Square root of that answer would get me about 16. If I round it to the nearest tenth, it'd be 16.5. Alright, 16.5, and I think that makes sense. It would be the longest side if you're looking at the angle measure. So 16.5. So that's how you use the law of cosines to find a side length. But you can also use it to find an angle measure. And really what you can do, you can use the formulas just like this if you want. And the missing part is going to be that angle at the very end. Or you can rearrange it, and that's what I've already done for you. If you'd like to write these down, I don't know that these are in your notes already, but I rearranged them just using the basic algebra, right, algebraic steps. I got cosine of an angle is equal to the two other sides that are not opposite of this angle, those two squared minus the opposite side squared, all divided by 2 times those two other sides. So let's just do one example of that, and I have it 3 different ways, but really they're all the same idea here. So if we have triangle XYZ again, XYZ, and I'm keeping this right here, this will help me. XY is 16. Whoa, whoa, whoa. That just went crazy. Alright, XY is 16, YZ is 12, and then XZ is 24. All we have is 3 sides. We have no angles. We don't know it's a right triangle, so we're going to have to use the law of cosines. To the nearest tenth, find the measure of angle Z. So this is the one we're trying to find. So what we're going to do is we're going to say the cosine of that angle, oops, I didn't do it there, is equal to b squared plus c squared. So the opposite two. So this is the one that's opposite. So we're going to use 24 squared and 12 squared minus that 16 squared. All divided by 2 times 24 times 12. So we should get an integer there, and when we do, let's do that here. I'm going to do that on my calculator. 24 squared plus 12 squared, which is 144, minus 16 squared, all divided by 2 times 24 times 12. I end up getting a small decimal, and I don't want to round it, so I'm going to keep it on my calculator, but it'd be about 0.805 repeating, I guess it looks like, would equal cosine of z. Now, you might remember to solve for z, then we do the inverse cosine. That's the inverse operation to get rid of the cosine. And we have to do the inverse cosine of this side as well. So really, z is equal to the inverse cosine of 0.805 repeating. I'm going to take the inverse cosine, put that answer in there, and I end up getting z is equal to 36.3, and that would be degrees. That would be the angle z. Alright, it needs to add up to 180. Alright, I can see that happening, that would be 36.3 degrees. Alright. Um, Again, if there was an error anywhere, please find it, but hopefully I didn't make an error in this one. If I labeled things correctly, um, all should be well. Alright, let's do some application. Actually, let's do two on your own. So I'm going to pause it, and I'd like you to pause it. Choose at least one of these to do on your own, and then we'll come back. Alright, so when you work these out, for number 4, you should get x. If you want to pause and look at the work, you should get x is equal to about 48.5 degrees. Y would be 36, just over 36 and a half, 38.5 degrees. Down to number 5, I got the length of x would be about 29.1, so it's the shortest of the three sides. And then the angle y would be about 76.6 degrees. So we're going to set up one word problem and we'll have you finish it yourself. It says the lengths of the sides of a triangular flag are 10 feet, 11 feet, and 5 feet. To the nearest tenth, what is the measure of the smallest angle? So now we can figure out from our knowledge of side lengths and triangles that the smallest angle is indeed this one right here. So we'll say that's x. And to find the measure of an angle, we're going to use the second way. So we're going to say the cosine of that angle x is equal to the two sides that are not opposite of it. So 10 squared plus 11 squared minus 5 squared, all divided by 2 times 10 times 11. And that means that the cosine of x is going to be equal to whatever that is equal to. So take out your calculator. 10 squared is 100. 121 would be 11 squared. Would subtract 25 from that. And then you divide that by... I end up getting about 0.89, 8909, then the 09 is repeating. So 0.8909, that part's repeating. So I take the inverse cosine of both sides, so x would be equal to the inverse cosine of that. And in my calculator, the inverse cosine of that gets me 27 degrees. So the smallest angle is 27 degrees according to this. So there's just a real world application. Looking at flags, um, architectural engineering things come into handy, anything with triangles and angles. So again, that's the law of cosines, just another way to demonstrate how to find missing side lengths or angles of a triangle. So please refer to that, refer back to that goal and see how you did and what you learned, any questions you might have. That's all we got on the law of cosines. We'll see you next time.